Everyone, welcome to this lecture. In this lecture, I'm going to cover a very important reaction named as Corey-House synthesis. Let's start with the topic. But before proceeding with this, kindly go through all the previous lectures wherein I have shared many tricks and concepts in a very detailed way. Hello everyone, welcome to this lecture. In this lecture, I'm going to cover a very important topic of organic chemistry named as Corey-House synthesis. Now, in Corey-House synthesis, remember, we can prepare unsymmetrical alkane. Okay, we have started in the previous lecture by Wood's reaction and by Kolbe's. Okay, by Kolbe's reaction, I can prepare symmetrical alkane. Okay, symmetrical alkane means the alkanes which are containing even number of carbon. Okay, even number of carbon. Clear? Whereas through Corey-House synthesis, I can prepare unsymmetrical alkane. Okay, I can prepare unsymmetrical alkane. Unsymmetrical alkane means the alkanes which are containing odd number of carbon. Okay, odd number of carbon. This is symmetrical alkane. Clear? Okay. Now, for example, I can take the example of propane. I can take the example of propane. Then propane, it is having 3 carbons, so this is odd number. Then same way, we can take the example of a pentane, heptane, and so on. Okay, so we are going to discuss more and more example based on the same synthesis. First, let us try to understand the Corey-House reagent. Now, what is basically Corey-House reagent? Now, Corey-House is nothing but it is a organometallic. It is a organometallic compound. Now, organometallic compounds already we have studied while studying the topic Grignard reagent, right? So, organometallic means a compound which is containing carbon group, that is the organic group. Along with that, it is also containing a metal. Clear? And organometallic compound in this case, we are going to use is Gilman's reagent. Okay, we are going to use is Gilman's reagent. And Gilman's reagent is nothing but we call it as what? Corey-House reagent. Clear? And what is basically Gilman's reagent, students? It is R2CuLi. And what is the name of this R2CuLi? R2CuLi. R is nothing but alkyl. Since we have 2 alkyl, I'm going to call it as a dialkyl. And then we have a lithium. Okay, and then Cu will be called as cuprate. Okay, it is called as cuprate. So dialkyl lithium cuprate is the Gilman's reagent, which is nothing but Corey-House reagent. Let us first have a look on the preparation of Gilman's reagent. Okay, we are going to prepare Gilman's reagent using different examples. Now, how I can prepare Gilman's reagent? This is R2CuLi. Let us take simple example. In place of R, I can take any alkyl group. Okay. Suppose if I have CH3, here I'll write down CH3, then I have Br. Okay. When the CH3 and Br, it is treated with Li, so 2 Li, in the presence of dry ether, what is going to happen in this case? The CH3 and Li will form a bond and Li plus Br. Clear? So this is the first step. Next step, I'm going to take this CH3Li, okay, 2 times 2 moles, and then cuprous iodide. So what is going to happen in this case is Cu, it will be bonded to CH3. Then again here I am going to get CH3 and along with this copper we have 2 Li. So one Li will be bonded to copper and the other Li, it will be bonded to I. Okay, this I. The other will go here. Clear? And this is nothing but I can see that this is R. Okay, so 2R. So which R groups are present? Methyl. So I will call this as R2CuLi, which is nothing but Gilman's reagent. Okay, and what is the example we have taken? This R is nothing but dimethyl. We have taken dimethyl. Instead of R2, I can write down CH3 twice. So this is dimethyl. Then we have lithium and then we have cuprate. Okay. So this is the example of Gilman's reagent. We have prepared dimethyl lithium cuprate from methyl bromide. Clear? Now suppose further this dimethyl lithium cuprate, I'll write down here. This is copper, and on copper we have a dimethyl group, and then we have Li. Clear? So this dimethyl lithium cuprate, when it is allowed to react with ethyl bromide. Now we are taking what? We are taking ethyl bromide. Okay. Remember what we have studied? We have what I have discussed. Remember what I have discussed? That in this process, I can prepare. Remember, at the starting only I have explained you. Remember, in the beginning only I have explained you that this particular process is used to prepare unsymmetrical alkane. So in the first step, we took one methyl group. Now I am taking two methyl group. Okay. First step, I have taken odd number of carbon. Now I am taking even number of carbon. Clear? Now what is going to happen in this case is, it is again very simple. This is Br, this is carbon. We know Br is having negative. This is positive. Clear? And here it is a copper, it is what? It is positive, right? So what will happen? And then this is negative. So this is CH3, it will go and combine with this positive species. Okay. So I will be getting CH3, CH2, CH3. Clear? And then definitely what is going to happen? This bond will break. And then we are left with what? We are left with CH3, Cu, and then Li. Cu, and then finally we are left with LiBr. Clear? So we have prepared a propane, methyl cuprate and lithium bromide as a byproduct. So as you can see, we have prepared propane, and propane is nothing but unsymmetrical alkane, or it is basically what? An alkane which is containing odd number of carbon. Clear? So entire thing I have explained in a very simple way, detailed way. Now what we can do is, suppose we were given CH3, CH2, CH3. Okay. Now we have given propane. Suppose if the question is, the propane is given to you, the product is given to you, you need to find out the starting material, or you need to carry out the entire reaction. Then how we are going to proceed? So in this case, whatever product is given to you, you just simply divide it into two. So I have divided, okay, even if you break this particular group, you are going to get one ethyl and the other methyl only. Okay, in both the cases, one ethyl, one methyl. Okay. Now in this case, what I'm going to do is, I'm going to take one of the alkyl group. Okay, I'm going to take one of the alkyl group with halogen, and then you carry out the same reaction. Okay, till you get what? Till you get the Gilman's reagent. That is CH3, CH3, Cu over here, and then Li. And then further this group, it will combine with this one. Okay, so this is CH2, CH3, and then you take one halogen, and then you will be getting the final product. So simply what I'm going to do is, the product I'm going to divide it into two. One will be the Gilman's reagent. Okay, one will be what? It will be from the Gilman's reagent, and the other one will be from the alkyl bromide. Clear? Now there is again very simple trick behind how to, now there is again very tricky part. Okay, which one you are going to take from Gilman and which one you are going to take from the alkyl bromide group or halide group. Now let us take one more example. Let us talk about now pentane. Now here is pentane, CH3, CH2, CH2, CH2 and CH3 we have, right? The question given to us is, we need to carry out this entire reaction, or they can also ask you which one is the Gilman's reagent, or write down the Gilman's reagent. Clear? Or the entire reaction you need to write down. So in this case, just now I explained you are going to divide the compound into two. So if I am dividing into the two, okay, I'm getting what? One ethyl, the other one is propyl. Even if I break from here, I'm getting the same thing, propyl and ethyl. Okay, you need not have to worry there. Clear? Now, coming to the reaction. Now we have ethyl and the other one is propyl. Now we need to think, right? We need to what? We need to think from which group the Gilman's and from which group the bromide group, alkyl bromide group will be coming. Now in this case, if I look into okay, understood. Now very important point is when this Gilman's reagent when this Gilman's reagent, it is attacking, okay, when it is treated with alkyl halide, what is happening actually over here? This Br, okay, this Br is what? It is a nucleophile. So basically, in this reaction, there will be nucleophilic substitution reaction. Okay, this is basically what? It is a nucleophilic substitution reaction. And we know that in nucleophilic substitution reaction, this is what? This is SN2 mechanism. This will be showing what? SN2 mechanism. And then we know that the reactivity order for SN2 is 1 degree is greater than 2 degree and then 3 degree. So the reactivity order is 1 degree, 2 degree and 3 degree. I mean to say, suppose if this was 3 degree, okay, suppose if this particular group was 3 degree, then definitely the SN2 mechanism, it will be what? It will be very poor. Yes or no? Because the reactivity order is what? Tertiary is very less. Why tertiary is less? Because in tertiary, there is what? There is a bulky group. There are bulky group. And because of the bulky group, the attack won't take place more easily. Okay, it won't take place easily because there will be what? Inversion because of SN2. So because of the bulky group, the SN2 mechanism is what? It is very slow or it will be least reactive. So in order to carry out the reaction, the nucleophilic reaction, this particular group should not be, it should not be, it should not be 3 degree. Okay, it should always be 1 degree or 2 degree. But most preferably, you just look into the compound, which is what? It is 1 degree. Now, how to use this concept and solve the next type of questions? So quickly, I'm going to look into the next question. Let us take question wherein we need to prepare pentane. Okay, we need to prepare pentane from Corey's house synthesis. So this is pentane. Now the very first thing is I'm going to divide it into two. So let us divide in this way. Even if you divide from here, even if you divide it from here, it is one and the same thing. Okay, we are getting ethyl and propyl group. Clear? So this is now one ethyl and the other one is what? The other one is a propyl. Clear? Now over here, what I'm going to do is I'm going to take the CH3, CH2, Br. This is the alkyl bromide. Then I'm going to allow it to react with lithium. So it will be giving me Gilman's reagent. So C2H5, I can write down this. Then Li and plus LiBr. And then further, the C2H5, Li, okay, twice of this. When it is treated with CuI, I will be getting what? I will be getting C2H5, Cu, C2H5, and then here it is Li plus LiI. So this is coming from Gilman's reagent. Okay, this is from Gilman's reagent, or I can also call it as a Corey reagent. Clear? Now the other part, the remaining part, okay, this part I'm talking about. This you can take it from, again, alkyl halide, CH2, CH3, Br, okay? And then you write down this as it is here, C2H5, this is Cu, C2H5, then your Li, clear? And then there will be what? There will be a reaction between these two. How the reaction will take place? Simply you're going to remove this Li and Br. Remove this Li and Br, okay? And then this thing, it is going to form a bond to this one. How the reaction will take place? I'll just explain you in a simple way. This is minus, this is plus. Over here, we have this as plus, this as minus. So minus will go and attack on plus, right? So I will be getting the structure C2H5, I can write it down as CH3, CH2, then CH2, CH2, and CH3. Clear? And then the byproduct over here will be LiBr. Okay? And then we have this C2H5 and cuprate. So this is how we are going to carry out the reaction. Okay? Now let us have a look on one more question. Now this question we can solve according to Corey house synthesis. How we can solve? Simply you need to prepare this alkane. But in order to prepare this alkane, what is the starting material? We haven't been given, right? So there are two starting materials. The first one will be the Gilman's reagent or the Corey house reagent. And the other one will be what? The other one will be the alkyl bromide. We are going to use alkyl bromide. And remember, this should not be, not be 3 degree. Okay, this should not be 3 degree. So if I break this one, if I break this into 2, so how I can break it? I can break it in this way. Clear? I can break it in this way. Clear? Now, this one is 1 degree and this thing is 2 degree. Clear? So I can see one is what? 1 degree and the other one is 2 degree. Why it is 1 degree and why it is 2 degree? I hope you know. This is 1 degree and this is 2 degree. So this entire thing is primary and then secondary. And then we know the reactivity order. The reactivity order, because this entire reaction takes place through SN2 mechanism. And then the reactivity order of SN2 is 1 degree is greater than 2 degree and then 3 degree. That means 2 and 3 degree are less reactive than primary. So over here we have 2 degree and 1 degree. So which one is more reactive? 1 degree. And which one is least? That is 2 degree. So this part, I cannot take it from the alkyl bromide. Okay, this cannot undershow me SN2 mechanism very effectively. Okay, whereas this one, it can show, cannot, I'll write down here, cannot show SN2 easily. Okay, this can show SN2 easily because the reactivity order of 1 degree is more than 2 degree. So this one will be coming from the B part. Okay, this one will be coming from the B part. And then the first one, okay, this group will be coming from Gilman's reagent. Is that clear? Okay. So how we are going to proceed with the reaction? I'll write down here. This is CH3, then CH, then CH3. Clear? And then I'm going to put Br plus 2Li. The entire thing will remain as it is. This is CH3, CH. Then we have CH3. Clear? This will become Li. Okay. And then the next one is LiBr. Okay. Coming to now the next step. The next step is reaction with cuprous iodide. So this will give me CH3, Li, plus CuI. Here it is CH3. This I am taking 2 times. Okay. So here I will be getting CH3 2. This I can write it down as a CH3 twice, then CHLi plus CuI. So over here I will be writing 2, then CH3 twice CH3 twice CH. Both of these will be bonded to copper, and then we have lithium plus Li. Clear? Okay. Now further what is going to happen? That also we know. It is CH3 twice CH. Then this entire reagent, Corey-House reagent, CH3 2 CH. Okay. Li plus. Now comes the B part. The B part is the one which undergoes nucleophilic substitution. And which is the B part we are going to take? We are going to take this as the B part. That is CH2, CH3. Okay. So I will be writing CH2, CH3 and this will be bonded to Br. And what will be the final product, students? This is a minus, this is plus. Here it is plus. Okay. This is plus. This is minus, sorry. And this is plus. Clear? Because copper is what? Copper is more positive than the carbon here. So what will happen? This carbon will form a bond with this carbon. Clear? And then I will be getting CH3. It is twice. So I can just write it down as a CH3. CH3 here. This is CH and this is CH. It is bonded to CH2 and CH3. And what will happen to Li and Br? This Li and Br, it will form a bond. Okay, so it is LiBr, the byproduct. And then what we are left with? We are left with this particular group. Copper, okay, we are left with this particular group. So I will be writing it as Cu, then CH, CH3 twice. So as you can see, the same product we have got, okay, whatever has been asked in the question, the same product we have, right, we have solved. Okay, the same product we have got. So this is how we are going to solve any question based on Corey-House synthesis. Clear? Let us take few more examples now. Quickly, you can note it down. One more question on Corey-House synthesis. Now, this is a question given to us. We need to prepare this question, okay, through the synthesis. Now, we don't know the starting material, okay. We have been given what? We have been given the product. Now, how to start with such type of question? Now, already I have explained you the trick. Simply, you are going to divide this compound into 2. So I'm going to break it. Okay. You can break this carbon, this one or this one. Okay. Any which way you will be getting what? The same component, same 2 components. Clear? So this is which group? This is methyl group. Clear? And methyl means this is 1 degree. Whereas this one is 3 degree. As you can see, there is a bond formation on which carbon? It is a 3 degree carbon. So this I will call it as what? Tertiary. And then what is the trick, students? We have studied in the previous lectures. The trick is we are going to take A and B and then I'm going to get this particular compound, right? The compound is given to you, given to us. This is P. Clear? Now we don't know what is A, what is B, but we know that in Corey synthesis, we are using Gilman's reagent, Gilman's reagent, right? The first part, the A part. And then the B1 is what? It is following nucleophilic substitution. Okay, nucleophilic substitution. And which nucleophilic substitution? It is SN2. And SN2, we know the reactivity order. 1 degree is more reactive than 2 degree is more reactive than 3 degree. So basically, what we are going to do is we are going to select the groups in such a way that the B part, okay, the B part, whatever we are taking, it should not be tertiary. Okay, it should not be tertiary. Because if it is tertiary, then it is least reactive, right? Because SN2, the reactivity order is what? 1, 2, 3. So if I'm using the tertiary group as B, it won't give us the final product because SN2 mechanism won't happen that effectively. So the B part, it should be primary. It should be what? It should be primary. And then which is the primary group in this case? This group, okay? This should come from B part and this group, it will be coming from A part. Okay? It will be coming from A part. Understood? Now, once we know what is the starting material, now it is very easy to write down the mechanism, isn't it? So how we are going to proceed? Let us start with the mechanism. Now, what is given to us? The B part is what? If I look into this B part, I can just write down the condensed formula. It is C, okay, C, carbon, and it is bonded to 3-methyl group, okay. So, this is the A part. So, I can write it down in the condensed form. So, this is CH3C and then Br, clear? And then plus, quickly, I'll write down the reaction. This is LiBr. Okay, when it is treated with Li, we get LiBr. And then what we are left with? We are left with CH3 3 times C and one more Li. Clear? And then this thing 3 C Li, we need to use it 2 times of this plus CuI. The mechanism, everything I have explained in the previous lecture. Kindly go through it. This is just the shortcut, the trick or the question. You can solve it within a few minutes, okay? Or you can solve within a fraction of second if you know the trick. Clear? So this will be C copper and then Li and then CH3 thrice C, okay? CH3 thrice C. So what is going to happen? Here, from here, this Li will go and attack on iodide and copper will attack on this carbon. Okay, so this is the, and we have one Li over here. So it is Li. This is the reagent we are talking about. And now this reagent, it is going to react with the B part. Okay, it is going to react with the B part. And what is the B part? We need to use a CH3 group. Okay, so I'll write down the reagent as it is CH3, 3C. Here it is CH3, 3C. And then we have copper, Li plus. And B part is CH3. It will be bonded to halogen. And in this case, now we know that Li, it is going to form a bond with Br because Br is minus. Here this is plus. Here this is minus. So what will happen? This carbon, it will go and form a bond with this carbon, right? It is going to attack on this carbon. Okay, this is what? This is showing SN2 mechanism. Clear? If this was a 3 degree, then definitely there will be lot of bulky groups. Okay, there will be steric hindrance, there will be lot of overcrowding, and because of that, the attack won't take place from the backside. Okay, the backside attack won't take place that effectively. Clear? And that is the reason why we have chosen this 1 degree group for the nucleophilic substitution. Clear? So this Br will be removed from here. It is a better leaving group. Okay. And then this carbon will attack. And we have on this carbon, we have 3-methyl group. Right? So I am going to write down carbon. Then we have a 3-methyl group. 1, 2, and 3. And then this carbon, it is going to form a bond with this carbon. And this is the product, required product. As you can see, this was the starting material which they have asked us to prepare. Okay. So the Gilman's reagent, that means the A part. What is the A part? The A part is nothing but this group. Okay. Clear? So this is how you are going to solve any questions on the same topic. And it is very easy if you know the concept, if you know the tricks. Clear? Let us take one more question now.